The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Thank you for attending today's webinar, MySQL 5.6 Advantages in a Nutshell. We'll begin in just a moment, but first I'd like to conduct a little bit of house cleaning. First, could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me. Okay, great. Thank you, everybody. I see that you can hear me just fine. Okay, next, during this webinar, you will all be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we will take the time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours. With that said, I'd like to turn the floor over to Peter Zaitsev, and Peter is Percona's CEO and founder. Peter, you have the floor.
Thank you, Lisa. Okay, so let us get started. As you can see, this webinar is about MySQL 5.6 advantages in a nutshell. And what we're going to do here is to do the brief overview of MySQL 5.6. There is a lot of stuff which is new in MySQL 5.6, and you could probably create 20 different webinars with different aspects of that. And what I decided to do is to provide the very brief overview, current basics, so then to get you excited about some features MySQL 5.6 has, so you can then explore them and to learn about more of them in their internet. Now, another thing to note is that the MySQL 5.6 has been out for a relatively short period of time, and there is not yet too much of real hardcore production experience yet. So this overview is mainly based on the documentation, experiments, right? And I would say as the time goes, you'll learn a lot more about the features which are discussed here. My focus of this presentation is going to be really on what those features are and why and when you may want to take advantages of them for your production usage. So it wouldn't be just academic relation. So let's look at MySQL 5.6 in general. And I see that as going to be the great release which will serve us very well for years to come. It has been GA for approximately a month right now, and it took about 2 years since MySQL 5.5 went GA. But actually it took a lot more time to develop some of the features in MySQL 5.6. For example, long time ago, approximately 7 years ago, when I was still working for MySQL, there have been initial work started on the Innodb Baltic search, which is first become available in MySQL 5.6. So this is a release which had an amazing amount of work put into that. Also, what I like about MySQL 5.6 is what it focuses a lot at the MySQL conventional use for applications which uses their MySQL the most, right? It tries to target the problems Facebook has or Twitter would have, not just their problems of some large enterprises with some very complicated stored procedures and advanced triggers would have. And that means it will cause an impact for pretty much every MySQL user out there. So thinking about MySQL 5.6, when do you want to upgrade to that? I typically like to start this question with thinking about what specific benefits are you looking from upgrade. In fact, we know a lot of users which run MySQL 5.1 right now, many years after MySQL 5.5 is released, and they're just fine, right? And so in some cases, it may take a lot of time before the upgrade is justified. So it's very important to understand what's the benefits you are looking to get from upgrading to MySQL 5.6. If you're starting to do some new project or plan upgrade, I think it's very good to start looking at it for development purposes and testing. After software is is that it typically takes a few months before many kind of small unexpected bugs are fixed or documentation is improved. And here is where your help is really required. Try the software, test it out, provide feedback, and that's how it can provide the most, get the most improvement over next few months to come. My typical approach is to upgrade within something like 6 months after the release is out to let all those baby bugs fixed, as well as really for ecosystem to get a lot more experience about MySQL 5.6. I like when I can Google about certain features and have a lot of articles about people sharing their production experience. Right now, time is simply too short to get a lot of that for MySQL 5.6. In some cases, the MySQL 5.6 advantages may be substantial now for you to do an upgrade a lot faster, but you need to understand you're also taking more significant risk in this case. I wanted to also cover briefly about the Percona and MySQL 5.6. From Percona side, we are fully ready to help you to be successful with MySQL 5.6. MySQL 5.6 is fully supported by our support consulting and remote DBA team, and support for MySQL 5.6 and various Percona software is either on the way or we'll have the versions supporting MySQL 5.6 released very shortly. I provide you a couple of links which you can follow from this presentation to learn more about this topic. MySQL 5.6 or Percona Server 5.6, that is what you get a lot of questions about that. And we have currently alpha release. There is few more alpha and releases going to come out before approximately 3 months after MySQL 5.6 release. We are planning for Percona Server 5.6 release, which will contain all MySQL 5.6 features plus their Percona improvements. We are not removing any MySQL 5.6 features from release. There is also Percona XtraDB cluster 5.6 plan, which I think can be very interesting product because it will essentially join a lot of MySQL 5.6 advanced improvements in all the areas, but namely in replication such as global transaction ID with Galera synchronous replication technology to make that a lot easier of use and even more reliable. So let's go back now to MySQL 5.6 features. I have split them in a number of categories which we'll go over one after another right now. First is scalability, and I believe a lot, this is probably one of the most important change in MySQL 5.6, a dramatic improvements in scalability. And I define scalability as some workloads where you are looking at cases of very powerful servers, being that with many CPU cores or lots of memory, handling workloads with large amount of data, a lot of tables, or a lot of connections. I define all of that as scalability, essentially being ready for very high end workloads. In MySQL 5.6, there have been a number of changes done on the server level, but when it comes to storage engine improvements, the focus was very much on Innodb storage engine. The rest of the storage engine didn't get any significant work, if any. So going through improvements briefly, we got the scalable read-only transactions, which is doesn't look like much, but that is very important for a lot of applications because in a web application specifically, in a lot of cases we have just transactions which just read from MySQL, and that makes very important. Concurrent Innodb data extension. This is something which you would either not care at all, or if you're somebody who runs Innodb with large amount of table, you actually may have a bottleneck and a lot of small stalls when Innodb tries to extend the data files. That issue was removed. Non-recursive deadlock detection, or I would also call it in general as more optimized deadlock detection. That really helps when you have a lot of transactions happen at the same time. The former versions of Innodb could spend a lot of CPU time trying to detect deadlocks, slowing things down, and not detecting the deadlocks very promptly. Faster locking primitives is something which work has been done on for actually a number of releases to date. In every release in MySQL 5.1 and 5.5, there have been work done to try to make locking primitives to be faster, because that is something which impacts every single workload out there. And again, improvements have been done in MySQL 5.6, especially on operation systems like Solaris or Windows. I would say Linux was pretty reasonably optimized as well. Innodb thread concurrency handling was also significantly improved. In some cases, even in MySQL 5.6, you will want to limit the amount of threads which are actually can be executed in a time, let's say, in Innodb thread concurrency variable. And making that more efficient than before is very good. Multiple background storage threads. In a lot of cases, when you would have a heavy write workloads at MySQL 5.5 and before, we could get into the situation where we can write to a database just fine, quickly enough. But the database in the background wouldn't be able to keep up with the amount of garbage, old unneeded data which accumulates. And it would accumulate more and more until finally, well, you have a very bloated and slow database, right, which is not a good thing to have. MySQL 5.6 solve this problem by allowing us to have multiple of those purge threads, really scaling the performance of the background purge. There is also improvements in a purge-like control, which is sort of a final last resort solution for purge problems. If you still kind of keep up with the amount of writes you're doing, you could configure MySQL, I think since version 5.0, to pause your write queries to let MySQL to keep up with the purge. The problem with that feature is it wasn't ever working properly until MySQL 5.6 that is. Adaptive flashing is also their feature which got improvements in a number of recent MySQL versions. And this corresponds to their being able to provide good and not good uniform performance with writes, not being bogged down by having to flush a lot of dirty data from Innodb buffer pool. I'm glad to see that is the improvement again, and there are more workflows which now can provide very uniform performance with MySQL 5.6 than ever before. Support for large redo logs also plays very well with that. Before that, redo logs in MySQL 5.5 were limited only to 4 gigabytes, which frankly was not enough to maintain very good and uniform performance, especially for systems with a large buffer pool and solid-state drives, because those could handle a lot of writes, and frankly those 4 gigs of log may just correspond to a couple of minutes of writes which system is able to accept, which is really not enough. And now you can go to much larger log file values. Split of kernel mutex, that is one of the most probably complicated projects which Innodb team performed in its MySQL 5.6 surgery. That was one of the biggest bottlenecks in Innodb, which is now removed. Data dictionary cache, which feature will apply to people which are running Innodb with large amount of tables, or better say very large amount of tables, something like 100,000 or more. Previously, in MySQL 5.6 and below, Innodb would have a data dictionary, but that wouldn't be cache. Instead, it will keep the data for all tables which have been ever accessed since server start in the dictionary cache, which frankly could waste a lot of memory if you have a lot of tables or partitions in the system. Now, MySQL 5.6 regulates that automatically based on your table definition cache variable. Another improvement which you got here is page cleaner, or we also call it a separate purge thread. Again, this would be relevant only to certain workloads. I think in their workloads with a significant read portion to them. Previous versions sometimes would have a challenge finding their clean pages in their LRU lists to replace, wasting a lot of CPU time on that, or sometimes doing that picks for pages to be replaced, impacting the overall system performance. Their separate flash thread or cleaner helps with that. Group commit for binary log, also very important thing, feature, which is something which was like added as a limitation, I think, in MySQL 5.0, and then it was gradually fixed multiple times until only in 5.6 we get a complete fix for a group commit. Then it works in all cases, even if you have a binary log enabled. And I will show some performance benchmark for that in a second. Another benefit is what there have been a lot of work done about fighting the flash cache coherence and file sharing. What those are is one of the few common low-level CPU optimizations, which can impact your performance dramatically when you're looking at the very large amount of CPU cores. So that was this optimization was done, and I think that's one of the reasons you will see MySQL 5.6 showing dramatically better performance when you're looking at 64 cores, right, or more. Memory allocation policies have been changed, which reduces memory fragmentation, which actually many of us could see as memory leaks in MySQL 5.5. We had many customer cases when they would run MySQL 5.5 and it would week over week increase amount of memory it uses, which really looks like a leak, like for all practical purposes. But in fact, it's not. It's just a memory allocation fragmentation, which comes with increased memory usage and gradual slowdown in performance, because the memory allocation starts to work slower than memory becomes fragmented. The memory allocation policy was revised in MySQL 5.6, and now it's both memory allocations should be improved, right, and performance reduced. Partition table locking was also revised, and how that will help you is what now partition tables become a lot more usable with large amount of partition tables, large amount of partitions. Previously in MySQL 5.5, you wouldn't be very successful running partition tables with more than maybe 100 partitions. Now you can go a lot higher, because only those partitions which will need to be accessed will actually need to be locked, right, in MySQL terms. There is also a number of things have been done to reduce log contention in relation to table access. We have a generally reduced log contention for something called log open, as well as we also get multiple table open cache instances, as well as multiple metadata log instances, which are all techniques for reducing contention for table cache, which is especially important for having very short, small queries. Let me share some results with you, which actually come from Oracle, which do illustrate their performance gain in MySQL 5.6. In this one, we can see, and these results from a sysbench, what MySQL 5.6 provides the most dramatic improvements when you have a lot of CPU cores, right, or CPU threads. And on the low number of CPU cores, their performance in that workload may be very similar, or frankly, sometimes even MySQL 5.6 can be slower. You can also see what's on their larger, and these are the results from a significant number of cores, right? We can see what then a lot of performance gains happen with large amount of connections, and results with lower number of connections are simply not shown on this graph, but results for 5.6 gains could be a lot more modest in this case, but they are very substantial, especially for medium number of connections, somewhere from 64 to 56. What I think is interesting to see from those results as well was that even though MySQL 5.6 is better, it's not a silver bullet. We still can have those the performance to drop down on the high level of connections, right? When we go to many hundreds of thousands of connections and active transactions, performance is quite likely to suffer. The group commit, which I promised, you can see that there can be substantial performance advantages with this fix, especially if single binlog is enabled. Now, what is interesting in this case is what this benchmark actually doesn't show a best case, because this system is rather powerful and it has a RAID cache, as I can see. The best case for the single binlog is when you're working with some very low performance IO subsystem without battery backup cache on rotating spindles, in which case you can have 10x or more improvement from having the single binlog from this fix for binary log group commit. Let's now move on to the optimizer and execution of fixes. There have been a lot of stuff done there. Some of us has those weird three-letter acronyms. The index condition push down. This is essentially, and I won't frankly go into a lot of details because all of those are complicated to describe, and to give you a good explanation, I would need the whole webinar for this slide alone. So I would give you those acronyms, and you can Google, and the MySQL manual gives a pretty good explanation on those. So what is the index condition push down in a nutshell? That allows MySQL to use index not just for lookups, but also for additional filtering, which can be applied to the columns which are in that index. The MySQL 5 and below would use indexes essentially either for resolving their index condition for lookup or as covering indexes. If index can be used as a covering index, and then after the lookup is done, then the row would be read. Sometimes even or in many cases, even then some other filtering could be applied for columns which exist in the index. This is actually very powerful optimization, and I think that's something which can impact a lot of your queries you're currently running without need to do anything. But batch key access and multi-range reads, this is something which often used together, as I will also show in benchmark, which essentially allows MySQL, instead of going with naive nested loops in query execution as it does for a lot of join, it can actually accumulate amount of rows it has to look up in the tables, right, or number of rows it has to be located from the single table by the index, and then execute lookups in a the most optimal order, which is important both because it allows us to reduce the disk sits. Well, if you're running solid-state disk right now, right, you don't care much about disk sits, but it also helps with the cache affinity, right? By accessing the data in their sequential order, we can do a lot better with Innodb buffer pool usage as well as a CPU cache, which can really provide a dramatic improvement to workflows. We also now got faster order by with limit execution if the column is not indexed. Previously, MySQL would essentially try to do complete sort and only stop sorting on the very last pass, creating potentially a lot of temporary files, right, and using a lot of temporary space. Now it can use a lot more optimal algorithm to do that, to do completely in memory as soon as the limit is long enough, which can be often several times faster. Persistent statistics for Innodb. This is something which I think you either wouldn't care about or you will just love it. Why? Well, because in MySQL before MySQL 5.6, the index statistics have been refreshed each time you restart MySQL for all Innodb tables. And what that meant is what sometimes you would restart MySQL, your statistics will change, and the query execution, especially for complicated queries, will change dramatically as well, right? Which often would cause things like, okay, I restart my MySQL server and now everything is just so bad. Then you have to go and restart it again, maybe a few times, until Innodb guesses the right statistics, right? And then workload runs again quite okay. In MySQL 5.6, these stats are persistent, so they are not refreshed on each restart, but stored in those special statistics tables, and you can then refresh them at your leisure when they're out of time of analyzed table, or also have automatic updates if table changes substantially, which is a lot better. There have been also a lot of improvements done in Innodb compression, which I think is getting a lot more relevant those days because of flash storage. As we get in the flash storage, we are again in the game of relatively is fast but relatively expensive storage. So if we can compress our data and use twice or 1/4 of the amount of space we would use before, then that can be substantial advantage, right? So I would encourage you to take a look at their Innodb compression features in MySQL 5.6 as well. Fast page checksum, that is also and the 8K page size support for Innodb. These are also optimizations which tailor towards their solid-state drives like workload, which can handle a lot of IOs, and which are actually quite good with random IOs, so we don't have to try to use larger page sizes to have our IO more segmental. These would make an impact only for some workloads when there is a lot of IO and then the rows are small and randomly accessed. But then these optimizations help. They can also offer dramatic help. So query optimizations. This is another topic which I would guess could deserve a wholly another presentation. There is a large number of subquery optimizations, and I think, well, the better way to put that is there are finally subquery optimizations for in MySQL, starting MySQL 5.6. What had been done before with subqueries was a very naive optimization for just the most basic type, and compared that to pretty much any other database that was very miserable. MySQL 5.6 now has quite decent subquery optimizer, which is able to deal with a lot of the most common cases which we see in the data analytics queries. The more efficient optimizer corresponds to their general refactoring of the MySQL optimizer to make it more efficient, especially when we are dealing with large amount of tables. Before MySQL 5.6, often we would look at the join, which join, for example, 60 tables or something like that, which some of our favorite ORM software could generate, and they could, and those queries could take a lot of time to be optimized. Often they can take longer time to go through optimizer stage and actually to be executed. In MySQL 5.6, optimizer was cleaned up, right, and it now handles those cases a lot better, as well as some others. These are the benchmarks I promised for BKA+ +MRR. This is from DBT-Free's data analytical query, and you can see what their difference in this case was essentially about 200 times, I also, at the peak, I also would note what with default join buffer size. The performance advantage was very small, just double, right? So that means is as we get into MySQL 5.6, there are some new tuning techniques we have to understand, and some buffers, such as join buffer size, gets a whole new meaning. In MySQL for 5.5 and below, join buffer size would only apply to essentially full join queries. It was almost never used, right? And you would mostly like to get rid of such queries altogether instead of tuning that variable. In MySQL 5.6, we have to, again, pay very close attention to what value we use this variable for. Now let's look at the MySQL replication, which is another area of a very significant work. We got a row replication, which is significantly better optimized. Now there is an option where we can store not the full rows, but only columns which have been updated, which can have a huge improvement in amount of data which is logged to the replication log and transferred through network, especially when you are doing updates to wide tables or tables with block columns. We get a multi-thread slave. I would say I would like to have seen more, right? Because multi-thread slave is rather limited, and it's only can run one thread per schema. But that already is a significant advantage from single-thread replication. And a number of workloads, such as multi-tenancy, may actually benefit from this quite well. We get a global transaction identifiers, which is one of those features which existed, I think, in Google Patch as much as 4 or 5 years ago. Not only we have, and these are kind of different, these are not based on the Google implementation, but which really helps us in managing the complicated replication topologies, right? Because now we don't have to try to do the math with different positions. We can just tell the slave to, hey, you know what, find where you left off that master and continue replication for that, making a replication a lot more useful. We also have a crash slave replication and vlog. Some of those features existed in a number of MySQL alternatives, some are such as Percona Server, but that's great, but that's finally in mainline MySQL. And now the expectations are you can shut off the power from the slave, right? Let's say you have a full data center power failure, and then it goes back online. It should be able to find the position where to replicate from, restart replication, and continue going without getting data out of sync. Replication event checksums, that is also pretty important. Or I would say it's a relatively small number of people have been ever affected by replication replication kind of query corruptions. But those guys who are affected, they just hate that so much. Especially this problem would happen in replication through wide area networks, right? It's networks which do lose packets or corrupt traffic. And things to note in this case is what in a TCP/IP protocol, indeed it has checksums itself, but these are not very adequate. And if you are replicating a large amount of data, then in some cases you will have errors which won't be discovered by TCP/IP checksums, and you will can get the wrong data propagated. In some cases, you will have it as wrong queries, right, or corrupted binary log files. And these are actually pretty good because that's you can spot those inconsistencies. But in many cases, those one byte off here or there will just be in your data field, which will cause silent slave getting out of sync. Now we get a rather strong additional replication event checksums, which can help us with that. Time delayed replication is very helpful, especially in environments with very high data recovery environments. Now I can set up a slave and tell it to be 1 hour or 3 hours behind. So if something happened to my main master, I have a copy of data going back a period of time without having to resort to restore from backends. Previously, that could be achieved by various tools, right, like Percona Toolkit, but it's a lot better to see that built into the server. Server view ID, in addition to manually the server ID which you have to assign manually, is great. We also have login, which is improved for low-level replication. And what I mean here is what now when we have a failure in the low-level replication, we can get not just information about their with cryptic error message about some handler error in right row function or something like that, but also information about the original query which caused the problem, which often can help us to understand where that problem can come from. For example, maybe you can say, oh, this probably comes because I have a mistake and I have my application right into the slave directly as well, right? I also am very happy that Oracle have invested a lot of time in creating those replication utilities for failover and administration. First, with new features like with global identifier and some others, it was very helpful to provide some easy-to-use way to manage those new features. And also, this is something which didn't get attention for years. I mean, for many years, we had lots of different utilities for application management, but no one would be official part of MySQL. So that's very good. That's covered. Here is an example of a multi-threaded slaves. Right? Again, I used the official Oracle result, and in this case, you can see there is substantial gains if you have a large amount of schemas. But again, that only would apply to the best case scenario when you have a large amount of schemas and all have a relatively uniform load within them, right? Let's look now at the transparency. There have been a lot of work done here, and I think that is a very important area which is often doesn't kind of get enough attention in the feature descriptions. This is important for us because in many cases we can really get a lot of mileage out of MySQL if you would only be able to understand why something we are trying to do doesn't work, why queries are slow, why something is not working, and so on and so forth. And those transparency features are exactly just that, focused on providing us more information. In MySQL 5.6, we got a lot more information schema tables. There is an Innodb metrics tables providing a lot of lightweight instrumentation for Innodb. There is a lot of table data, metadata information corresponding to information about indexes and tables in Innodb, which is very similar to what you would previously find in Percona Server. We also got the buffer pool content information tables, which are also very helpful for troubleshooting some workloads to understand, hey, you know what, this query is slow, well, but that's because I'm not getting the table cached in the buffer pool. Oh, why is that? Well, because something else is taking space up there, right? That's very helpful in some cases. Improved explain. I'm very glad we don't have to rewrite explain any longer to handle up in sort of the Innodb queries. And also they have a JSON output, which in fact provides a lot more information than standard table-like format, which allow a lot of tools to be built, helping people to optimize queries better. There is also other features in transparency, like optimizer tracing. You can understand why optimizer is speaking one optimizations one way. There is a deadlock login. You can log all the deadlocks now if you like, not just the last one, which can be a lot more helpful than log troubleshooting. There is also get diagnostic statements, which can run after the statement and get a lot more information about the statement execution and errors. Here is some example I have provided for Innodb metrics table. You can see, unlike the show status output, which provides a lot more information in terms of current count, we can look at the mean, max, average, right? We can also really enable or disable tracking metrics. I think by default, Innodb is going to be tracking probably about 60 out of 200 metrics it can potentially count, right? Which can be, so if you're working with some complex performance diagnostics, you can enable more metrics and get a lot more insight about what is happening on the Innodb level. Here is explained for JSON for delete statement, right? First of all, they are able to get the delete, explain for delete statement, and then you can see in JSON output they're getting some more information. What I like here is, for example, that last line with attached condition, which actually says me, oh, that clause from a query maps to this index, right? It is obviously trivial in this query, but if you're looking at some very complicated query, then it may not be trivial to see which query conditions are mapped to different indexes and where it's working as we expect. Performance schema, that is also a great big feature in MySQL 5.6, which I find a lot more usable than in MySQL 5.5 before. The overhead was reduced, even though I can still find workloads where overhead can be 20% plus, especially if you enable a lot of measurements. The simplified configuration, right? It's more simple to configure, and it makes an assumption about default configuration in a lot of cases. Table access was instrumented, statements instrumented, so we can track which statements are taking what time, different stages in the statement execution, and so on, and so on and so forth, right? So that is just dramatically improved, and I would suggest you to check it out. Now, I would say I haven't found all the things that's quite expected in information schema fill, right? One thing I remember mentioning, like, hey, we aggregate the data by user, and I expect the feature somewhere comparable to the user statistics feature in Percona Server and MariaDB, which was originated from Google and I think actively used in Facebook. But looking at this user table, I see what it only provides us the current connections and total connections compared to a lot more information being able to measure different users in their. This example is from Percona Server. Operational improvements, that is another thing which is very important for us. With MySQL 5.6 being providing a lot of features for DBAs to be more efficient. We have a separate table spaces for undo loops. Very valuable, right? Because we won't have any more risk problems with table space size run away because somebody had been running very long query, right? And we're having a lot of undo garbage accumulated, and now we have no way to get rid of that other than reloading the database. Faster start and Innodb buffer pool preloaded. That feature also exists in Percona Server before, and I'm very happy that it's is picked up because before that, if you would restart MySQL on system with few hundreds of gigabytes of buffer pool, it may take a long hours before it warmed up and actually reach its peak performance. Online DDL, that is one of the probably most asked features, right? Running either table on the large table could take days, right? Well, and now it still can take days, but now the table will happen online. The table will be readable and writable all the time. We have an import and export for partition tables. That is one of the main features which from merge tables which didn't exist for partitions, now it was replaced. We have remote binary log backup to supplement their a lot of good backup practices. Right now we don't have to create a cron job to get a copy of a binary log every 5 minutes in case server goes back in flames, right? And we don't want to recover to just state of yesterday. We have an Innodb transportable table spaces, also very important, right? If you have to move tables between the servers, we don't want to go through MySQL dump, well, because it will take a lot of time. Now that is removed. We got a lot better configuration variables by default. I would say if you still want to tune MySQL 5.6 to get a best performance, by default variables are a lot better for MySQL 5.6 and MySQL 5.5. We also get the user-defined data directory for Innodb tables. That is very appealing if you are using mixed environment and you want, from a storage standpoint, and you want, for example, some of the tables to be placed on solid-state storage while others remain on conventional storage. Right? That allows you to do that without some hacks with symlinks which will be overwritten by the next alter tables. We also get something as a connection attributes which allow us to have some unified way to supply the information to MySQL about the connection, what application coming from, maybe who is the user, and so on and so forth, which can help a lot in advanced origin and troubleshooting scenarios. Now, some features which MySQL 5.6 adds for developers, and I would say this list is somewhat surprisingly small for MySQL 5.6. There is no too many features in the list, right, which are developer facing. There is memcached API for Innodb, which was added. There is an explicit partition selection in the queries, which is pretty advanced feature, but that can be very valuable if the optimizer doesn't pick up the proper list of partitions for you, right? Or if you know more about the query to do that. That can improve performance many times in some cases. Full text search is finally available for Innodb, so there is one less reason, right, to stick with MySQL. Even though I would say that the full text search for Innodb is substantially different for Innodb and MySQL, and the results can be different. And you can check out the series of articles which is being written about that in MySQL performance blog. We finally get a microsecond time precision and other types like date time, which is great and save a lot of developers from using big int or some other ad hoc columns for storing time information. Then we have to do that. And we also have precise spatial operations for JS functionality, which is pretty important those days as we have more and more applications which are built around geolocation technologies. And in this case, we often have to have a very good understanding where, to what object the given location belongs. So that's important. There are a number of extensions in the security space too. Now we have a passwords are hashed in the query logs. No more clear password in the queries, which is pretty good. We have SSH 256 with salts, which can be used for authentication. We have a support for obfuscated password storage for command line tools, right? So you don't have to, let's say, just put the clear password in your MySQL and in the home directory. Though I would say this kind of, I'm not sure how much security feature that is, because it may give a lot of people a false sense of security, because these obfuscated passwords actually can be decrypted to get a plain text password pretty easily by any experts, right? And there are already articles about how to do that online. There is support for policy-based password validation. That means we can now set up passwords to expire or require minimum password length and so on and so forth. And we also got the plugin authentication support and replication, which is, I think, very valuable if you are using their plugin-based authentication in general in your organization. You may want to have that replicate using plugin as well and not have to have the special authentication scheme for application. Well, that's about it when it comes to their meter presentation. I'm sure you would like to learn more. And as I mentioned, you need to learn more because that just barely touches the subject of MySQL 5.6. I would suggest encourage you to go to check their MySQL 5.6 manual, that I think is a pretty good description. as well as number of articles at dev.mysql.com. Check out blogs. I value blog at Innodb.com. The Innodb team provides a very good amount of in-depth technical information out there. planetmysql.org, where there's an aggregation of a lot of blogs, and if you are in MySQL space, you definitely want to follow that. We'll also expect to be writing a lot about MySQL 5.6 and MySQL performance blog over months to come. This is, of course, a very big event in the MySQL space. You have a chance, join us for Percona MySQL conference and expo. To happen in April in Santa Clara, and this it also will have a lot of topics about MySQL 5.6. And for attendees of the webinar, we are happy to offer their 15% discount code, which is described on the page. Well, that's it for me, and I will be happy to spend the next 10 minutes to answer questions we have. Alisa, that's all yours.
Thank you very much, Peter. Okay, so there are a bunch of questions from the audience, and we will get to as many as we can. And those that we don't get a chance to answer, Peter will address in a blog entry on the MySQL performance blog, which he provided a link to in the presentation. Okay, Peter, your first question is, are there any plans for decoupling a transaction from a single connection, and by that they mean session, to allow for parallel processing while maintaining isolation semantics?
Yes, well, first let me say what, when it comes to MySQL roadmap, right, I'm not the right person to ask that. That is, the Oracle has decided that, and they are not very forward about what to expect in the next release, right? So I think you are right, and indeed, if you look at the MySQL feature, it has support for some of those XA transactions, but so far that support was pretty rudimentary, right? And it doesn't allow us to make their multiple connections as a part of the same transaction.
Okay, great. The next question is, are there any plans for decoupling a transaction? Oh, I'm sorry, that's the one I just asked. This is related to Innodb. Is any work being done on eliminating the IB data 1 file, which continues to be an albatross for large deployments?
Well, there is no eliminating of that file, right? It still contains their Innodb data dictionary and so on and so forth. But if you look at that, typically that file would have this data dictionary, right, plus some small things like double write buffer, and the majority of that space may be used by this undo segment, which, as I mentioned in the presentation now, can be stored separately away from that. That really removes a lot of focus from that file. Now, also because we have the transferable table spaces in MySQL 5.6, this kind of also goes to tailor to that issue of some data stored in the individual table sizes, but we can't just move them separately because some data is stored in the EB data file.
Okay, and the next question is a clarification question. By data dictionary, do you mean information schema?
Yes, well, I didn't quite, I think you could cut up a little bit, but I think I got the question. So when I speak about their information schema, right, this is essentially an interface to be able to provide some information about MySQL. Some of the data what provides come from tables, and now it could be coming from something else like buffer pool content that doesn't have anything to do with tables per se. When I speak about data dictionary, right, we're talking about the information which Innodb stores for different tables, right, in memory, which typically keeps information about what indexes tables has and so on and so forth, right? And this information is also available through information schema, but these are different things.
Okay, great. Thank you. The next question, will this version contain some type of profiler tool like Microsoft SQL Profiler?
Well, so when you look at the profiling tool, like I have been covering the server component in this case. Then there is a number of other tools which are being developed by both MySQL and other teams which have a will be able to use a lot more server functionality in MySQL 5.6 and provide more advanced profiling tools. I know there is a number of work has been done in MySQL Workbench to be able to profile your queries there using MySQL 5.6 features.
Okay. What is the biggest advantage of allowing a larger than 4 GB redo log file size?
Yeah, so, if you look at how logs relate to Innodb, the flash of the data from buffer pool, you can think about that this way, right? For each circle through the whole binary log size, every dirty page from buffer pool has to be flushed, right? So now if I'm writing a substantial amount of data in the logs, then it may be I have to flush all my dirty pages essentially every few minutes, which is very inefficient, right? That means I have to do a lot of flushes, and that has all kind of impacts, starting from it's expensive, right, performance overhead, to things like it reduces lifetime of my solid-state devices because they can handle only so many writes. If I have a log files which are much larger, then I may be able to get those period of flashing just to be tens of minutes, right, or sometimes even more than that. Now, I would also say, why do we come to that only right now, right? What is the problem of large log files? And the problem of large log files is the larger log files you have, the longer recovery time Innodb may have. And I would say only with optimizations done in MySQL 5.5 and at the same time solid-state storage, which can do tens of thousands of IOs per second, we come to a point then we can have both log files but keep the database recovery time reasonable, right, if a crash ever will happen.
Okay. Does 5.6 have any prepared statement optimizing, that is, caching query plans with a prepared statement? Well,
as far as I'm aware, there haven't been significant changes when it comes to prepared statements. And in general, it was always kind of a little bit tricky. MySQL would already cache some of the plans for prepared statements. What it wouldn't do is it wouldn't share prepared statements, right, and the cache plans, right, of course, within the threads, right? So that will limit that somewhat. And also, it will not cache a full plan, but only partial ones. Why? Because there is a substantial difference in the plan which could originate from different constants which you pass to the same prepared statements, right? And an optimizer tried to be, well, not to fix the plan too much, right? So then it would use their own plan for a different constant which is supplied in a different prepared statement execution.
Okay, we have time for one more question, Peter, and that is, in a new setup, would you recommend to use the new Galera-based replication, or would you recommend to create an old but known traditional master-slave setup?
Well, I think this is a complex question, where the Percona XtraDB cluster and other Galera-based products, I think they are really great concept which can work very well for a number of workloads, but it is also a little bit different, right, from the conventional replication, right? So you better to validate and test how your application will behave in that environment, and also understand what kind of advantages are you are planning to get to that setup, right? So I don't want to say what this product is a silver bullet for a lot of applications, but that can really offer advantages for a number of them.
Okay, well everybody, thank you so much for attending today's webinar. As I've said before, any questions that we didn't get a chance to answer, Peter will address in a blog entry. And please expect the delivery of the recording of this presentation in the next 48 hours. And again, thank you so much for your time today.
Okay, thank you.